Okay, this video right here is going to have a little bit more, quite a bit more detail than some of the other videos produced. There's a lot of complex stuff in here, but it can be understood. It's very important to understand it, so I'll do my best to give you the information needed to understand it. So each one of these green boxed in areas right here are solar eclipse occurrences on the NASA SARO cycles. The red ones are non-occurrences on the SARO cycles. You see right here where it says spring, that will be all these right here will align at a 90-degree angle to the galactic plane within 36 hours of the spring equinox. The winter, all these will align to the galactic plane within 36 hours of the winter solstice. Fall, same thing, within 36 hours of the fall equinox. All these down this entire line right here will align at a 90-degree angle to the galactic plane. And of course that's going to be exactly 180 degrees across from the spring. 180 degrees from spring to fall, 180 degrees from winter to summer. Aligned to the galactic plane, aligned to the galactic plane. 90 degrees to the galactic plane, 90 degrees to the galactic plane. All these in the whole entire line will align there. The greens, again, according to NASA and the SARO cycles, only the green ones will produce eclipses. The reds will not. But remember now, the reds will align in the same exact place. They just don't produce an eclipse. So, if you check out this area right here that's highlighted into this green dotted line right here, all these 20 that are in here, you can see where the now time, or this current time, 2020 right in here, 2001, center time in here, all these are occurrences, solar eclipse occurrences. These right here that don't have dates on them, or they're in the penciled in area right here, those will not align to the galactic plane or 90 degrees to it, right? They land about 10.8 degrees on an average off of their mark. So, just explaining what those are right there. And, alright, so between each one of these right here, from this one right here to this one, is 19 years. That's that 19 right there. These are year markers. The 19, 19, 19. You see this 315. That's a 19 plus a 296. So it's going to jump from this 1862 to 2177. So it's 315 years from here to there. There's also these 296s right here. So this is going to go from 1719 to 2015. So just pointing that out so you can see that right there and understand what those are. In their movement all the way down this entire paper. All these will do that. They have 315s and 296s and 19s years. Those are not approximations or sort of around there. They're exactly that number of years within just a few minutes to a few hours. And that's on an average too. So it's just the nature of the way these eclipses move. They don't have an exact time that they are. So the numbers listed on here, the 19, the 296, and the 315, they are averages over the whole duration of all these eclipses on here. Just want to make that understood on there. So And the same thing for these right here. You can see these 33s. I just put them in 33s. And the 144s, you can see them moving in pairs right here, where it's a 33 and a 33 and a 144 and a 144. Those are, I've listed them in there that way just because it was easier just to write all that in there without putting in this, because this is what it really is 143.75 years. And the 33 is a 32.75 years. So all of these right here from season to season across this move in that exact pattern right here. All of them. 143.75, 143.75, 32.75. Moving in pairs. 2, 2, 2, all the way across. Again, what that's doing is moving from spring to winter to fall to summer. Okay, we'll start back at the way where we were right here. Spring, just moving around this way. Spring, winter, fall, summer. Okay, going just like this. There, to there, to there, to there. Okay, there, 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 there. 90-degree angles from each other. They'll all do this, every single one of them. Every single one of them on this paper will do this. So, as you'll notice, these all these that are within this green dotted line here, all the wings that are green boxed in, that will actually land on their quarter markers, as we just discussed right there. Okay, these 4 points. You can see the center time or the now time right in here. There's 2020, the 2001. All of these are occurrences. They're eclipses that land within 36 hours of either an equinox or solstice. Either, again, the winter and summer will land on the galactic plane. And the spring and fall will land at a 90-degree angle to the galactic plane. Okay, so another thing I'll point out right here before I forget is that this paper right here is designed in this way where you can track the time and movement horizontally right here, and you can also, of course, do it, and you can do it vertically. So there's a repeat in here. You can see right here the 2020 and the 2001. It's the same right over here. Same in this block here, 2020-01. You can see this one right here is the end of this side over here, 1805, and you got the 1805 over here. So this is a repeat also. So you can see the backwards movement of the time going this way from here, right? You can see it all going that way back in time. Whereas this one over here, you can see the same thing. It's the repeat and then repeat right here. This is the 2177. And there's the 2177. So now, from this side right here, you can move all the way forward in time. Okay. So, all right, next. When you take this this green dotted line area right here and you move back in time, you start to get, you know, red ones are starting, meaning non-occurrences on this, on that. Remember now, these are all moving exactly this way, where it's moving in this pattern. 19 years, and the 315s. And well, inside of this block, there's not a 290. Well, there's a 296 right there, but these are all connected in here in 19 years, 315s and 296s, exactly in years, and then 32.75 years and 143.75 years, all connected together, doing this right here. in this time right here, in the current time, in the center of this highlighted area, all green. You move backwards in time, not so much. Move forward in time, not so much. Starting to fade away. You move backwards in time, more, and you're going to get red ones. Okay? If you go backwards in time further, remember this is the same block right here. This highlighted area is the same one. So, but here you can now see backwards in time further. So now watch this. You go backwards in time further, and you're going to get reds, greens, red. There's a green, and all red. This whole entire pattern right here of this happening doesn't exist anymore back here. Moving in exactly the same way. Let's start from here now and go this way. So none of this is happening back here. Again, this is the date of 784. They start to move into their positions. You have one that's aligned on the summer solstice and to the galactic plane. You have these over here, also to the galactic plane. Start happening. Not happening. Start happening. A little bit. Moving forward, start happening a little bit more. I have a whole entire line right here. I have an alignment to the galactic plane in the winter. We have an alignment, 90-degree alignment on the fall. Okay, summer, spring, or sorry, summer, yeah, summer, spring. It's hard to see through the phone at the same time as looking on this. But anyway, there they are, those four right there. So, again, okay, moving forward in time more, they start to develop more. Start to get themselves all organized more. They're aligning to the galactic plane. They're aligning 90 degrees to the galactic plane. And within 36 hours of the solstices and the equinoxes. And somehow, miraculously, again, they do this right here for this time period. From 1805 to 2215. Every single one of them falls in there like clockwork. Then the clock starts to get broken. The order's breaking. They're falling out of order here. Okay. Falling out of order. For this, we have to move back up to this block here. And again, this right here would be the same as this one over here. So you're moving forward in time. So now we're going to just skip over to here. So you can see forward in time more. So you just go from there down. And again, they just fading away. The eclipses are not occurring in that pattern anymore until you get down to this one right here. Again, there are no occurrences down there anymore. So same as the other papers. Giant question is how can it do that? I can go from this, moving forward in time, to get to this. Moving it forward from there, again, don't forget this part. There's our current time right there. Moving it forward from our current time, they all go out of existence again. Till they completely go out of existence right here. So this might be a little bit of a lengthy video because there's a few other ones. That's the first paper I drew on this one right here. And I moved on to drawing this one right here. which is the same as this one basically, but it is kind of arranged in a different way. You can see all these right here where it has this L1, L2, L3, and L4 and repeating down there. Same as what it is, you know, right here where it has the spring, winter, fall, summer repeating. But this one is turned around in a different way where you can see the L1, 2, 3, and 4 on here up on that side, and then the seasons are right here: fall, winter, spring, summer. Okay. So I'm not going to explain why I've turned it around that way. It just is that way on here. Plus, the other thing that happens on here is you can see the timeline is moving the other direction. These right here are the years. And so those are way up in the future. And on this paper up on the top, they're actually in the past. So this is quite an incredible paper right here too. And what you get by arranging it in this way, you can see these patterns right here where these from L2 or from L3 to L4, just going on this one right here, you can see where this has this 296 years from this year to this year, 296, and then they go into this pattern of 19 along here. So to show you, like this one right here, these are all 19 apart. From there to there is 19 years. From there to there is 19. From there to there is 19. And from here to here, which again is a non-existent one, but it's 296 years to this place right here. Non-existent meaning that it won't align to its, what is that one, a winter. It won't align to the galactic plane right here. But still, if you go, the interesting part about it is if you go from right here to here, 296 years, then you add another 19, right? Then you get to here, which is now going to be still back on the winter line. So it skips over here. That's what the 315s that are over here. Yeah, 315. That is the 315 right here. The 296 plus 19 from there to there is 315 years. So again, if you look at this whole entire sheet right here, all these are 19 years apart. From there, that one to that one. 19 years from there to there. That one to there to there. Okay? 19 years. 19. Again, over here it has these 296s. Some of these 296s from this one to this one does occur here, meaning that it's not a 315. It's a 296 because it doesn't have this blackout period right here, like this one does. So from here to here is 315. From here to here is a 296, and then the 19. So again, you can see here's an interesting thing on some of these right here. You can see these huge lengths of time where these have these eclipses that occur on the Saros cycles. Like you go back in time right here. And there's a start on this one over here, all the way over here. You can see this one at 1262. The rest of them are all red down here. None of these are going to be eclipse occurrences, but like I said, they do fall in their position right here. So every one of these will fall on their mark right here. Here, 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 and here again. Okay, just pointing that out again. They just don't produce an eclipse according to NASA. Then, starting in 1262, it will produce an eclipse. Not an eclipse, not an eclipse. Produces an eclipse right inside of here. 2001, 2034, okay? All through here, they produce these eclipses. In 2321, will not produce an eclipse. Again, it's going back into this non-occurrences. All the way back there, okay? That's on L3, L4. Nothing back here. Moving up in time. Get one in 1634, one in 1667, 1700, no. 1843, here's our current time again. Whole bunch of them happen in our current times here. And they fade out of existence right here. Okay, L1. L1 has quite a long stretch on it. Check this out. 0518, nothing up to here. Has one in 0904. Am I looking at the right line? Yeah. Anyway, L1, so you have 1904, 108 here, okay. Non-occurrences. Okay, so the L2 right here, back in 537, no occurrences. Start to occur in 1099. Yeah, this is the one I was, somehow I think I got lost there for a minute. Looking through this phone right here, it's like, so the 1099, this is going to have a stretch all the way through here. You can see this 1099, all these are going to be occurrences right through here. Again, here's one that's doesn't exist. It means it does not have the alignment. It's 10.8 degrees off its quarter mark. Okay, that's what these are. Remember that. And so then going back here, you have these right here. 10.8 degrees off its quarter mark, each one of these. Back onto its quarter mark, it has an eclipse that occurs, has an eclipse that occur. Off its quarter mark, back into here where these eclipses occur, and then non-occurrences right here. I'm going to point this out again, don't forget that all these are moving in this pattern of 19 years, 296 years, okay? Very nearly exactly this number of years. It's like, again, only off by, on its average is only off by minutes. They can vary from one eclipse to the next, plus or minus, a few hours. So we have all these that happen that way. So there are some more things to explain here, but I think that's going to be it for this paper, because there's another one to move on to. So from that one, I went to creating this one, which is also another absolute masterpiece of a paper. This is going to get into something that I haven't explained yet on this channel and with these papers and videos on here. So this is going to get into some more detail and even a bit more complicated, complex. So here's a super interesting thing that happens in here. Every one of these, again, are moving in these 296s and these 19s right here. Okay? And these numbers that are on here, okay, you see this 38? 38 equals the Saros cycle number 150 right here. I'm just going to show you a few of these. Not in very good order here. I'm working on too many different stuff in here, but here you can see this one's a 32. That is the Saros cycle number 120. Okay. Here's a 30. That's the Saros cycle 148. And these are all the even ones that we're showing you right here. This is the Saros cycle 28. Or not, sorry, number 28, Saros cycle number 138. Right there, okay? So, why I show you that is because the order in here on these, the 38 that are shown on here, are all in an order in the way that they fall in an 18.03 year period. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8 in an order like that over an 18.03 year period. Like I said, this is going to be probably way more complex than people can understand for me to explain this in a video. So what happens in here with this is in that same order that they fall. Let me see if I can find this other paper I have. Yeah, this one. Explain this a little better. You can see these right here. See? 1, 2, 3, 4, 5, 6, 7, 8. Okay, the ones that I was just showing you on the, like this 28 right here. That 28. You see right here where it says 28M. Right here, 28M. Okay. The 30 is 30C. 30C right here. Okay. So, it's good I have this paper out right here because I can explain this to you a little bit more clearly. These are all falling in exactly this order. So 01 is, it would be falling in the year 2000. 02 would fall in 2000. So it's falling in order. This eclipse occurs. Then the next eclipse that occurs is right here. The next one after that is right here. Next one, next one, next one. 1, 2, 3, 4, 5, 6. So this is numbered in their occurrence. Okay. So you get the same thing happening here, which is really absolutely unbelievable to see this, because these are all moving in a pattern of, you can see right here, if you want to go check starting from the 01, it's going to go 01, 02, and then it's going to skip, have a 7 skip, then it's going to skip another, it's going to skip another 7 right here, and it's going to go to 16. Then it's going to go 16, 17, 18. Skip 7 to 25. Skip another 7 to 32. Then it's going to 32, 33, 34. Okay, all the way down through here. It's going to do the same exact thing over and over and over. So now we'll go to 34 to 03. It's going to be 34 plus 7. Okay, because these only go up to 38. Remember that. They only go up to 38. So it's going to go 34 to 38. It's going to be 4 plus 3 is 7. Okay, then it's going to go 03 plus 7 to 10. It's going to go 10, 11, 12. Plus 7 is going to go to 19. Plus 7 again is going to go to 26, 26, 27, 28. So you can do this pattern all the way through here. You can see the 1, 2, 3 right here. It'll go 1, 2, 3. Okay, then it's got a skip in it. It'll go 1, 2, 3, skip. 1, 2, 3, skip. 1, 2, 3, skip. Okay. So that's pretty impressive. That right there did not happen from the Big Bang. Okay, this is created by intelligent design. So, moving further into what this is right here, is these have this additional pattern that happened here when you're doing this 1, 2, 3, 1, 2, 3. Now you're going to get 1, 2, and 3. 1 group, 2 groups, 3 groups. 1, 2, and 3. Okay, next I'm going to show you this right here, where these 1, 2, 3 groups in each one of these groups right here. It's now going to go 1 group, 2 groups, 3 groups. And each one of these groups right here. So also, I'm going to jump over here. There's this, the timeline on this is moving down. Timeline moves down this way, and time goes up the chart that way on this, okay? It also has a down time moving that way to the left, and up moving to the right. So I wanted to point that out because moving up in time, let's just go from this block right here, from 13 is going to be 13 plus 22 of these, again, these right here. So you move from 13 plus 22 of 38 that there are in total is now going to give you the 35 right here. It's going to be 13 plus 22, again moving up in time. So you move this way, it's going to give you 35. 35 plus another 22 is going to give you 19. Again, remembering that after 38 it has to start over, so it's going to be 35 to get to 38, that's going to be 3. And then plus the 19 is going to give you the 22 right here. So, okay, every single one of these is going to do that. Every single one of these is going to be 22 of these, of the 38 right here. So, moving on from that, what you get is inside of this whole block of this 1, 2, 3 now, you're going to get a total of 66 in there of a movement. 6 plus 6 equals 3. The total time duration that's going to happen in is going to be 1,059 years. That's an exact average. Okay? Means that if you do this over and over, it's going to be this right here as an exact average of exactly 1,059 years. Which is 1 plus 5 plus 9 equals 15. 1 plus 5 equals 6. Okay. Over here, this is the number of moons that will happen in that same time duration right here of 1,059 years. There'll be 13,098 orbits of the moon around the Earth, which its digital root comes to 9. And the entire distance when this of its time duration from this timeline from right here, from where, yeah, well, from this 31, no, actually, sorry, it's been a little while since I looked at the page. So 3606 years from the 01 right here, going all the way through here before this whole pattern recycles again, starts over to the 01 right here. That time duration inside of this now as a block, right, comes to 3,606 years, which is going to be 6. Okay, but right here you have a 3, 6, and 9 pattern inside of here. Moving over onto the other side of the paper, it gets even more incredible because every single one of these is moving at a 90-degree angle to each other. 90 degrees, 90 degrees, 90, 90, 90, all the way down here. Except for right here, it's an interesting little skip in the pattern right here. It's going to move 180 degrees right here. It's still 90s, except for that this one right here is not actually a 90. It doesn't go from 90 to 90 here because this does not land on its quarter mark. Remember, this is one of those ones that lands 10.8 degrees off of its, on an average, 10.8 degrees off of its quarter. So you don't get 90 degrees from here to here, but you do get 180 degrees from this one to this one. Okay, so that's the only place that this occurs on. All these rest of these are 90s from each other to each other. So the number of eclipses that occur between each one of these are moving in this 69303. This is the number of eclipses that occur, total eclipses that occur, not total, like the total number of eclipses that occur from this point right here to this point is going to be 69 eclipses. This one right here is 303, 303, 69, moving again in pairs of 69 and 60, pairs of 69 and pairs of 33. Now, the digital root of 69 is 6. Digital root of 303 is 6. So you get all these 6s across here. All this is going to be 6. Digital root of them. So when you add the 69 to the 303, you're going to get 372 total eclipses at 180 degrees apart. 302 equals 3. All these will equal 372 across here. Except for in this skip part right here. 372. Those 372, when you add them together, they're going to give you 744. That's now going to make one from right here to right here, or 360 degrees across from each other. So it's going to go from here to here. It's going to be 360 degrees. That 360 degrees is going to give you right here this 744. That's total number of eclipses that occur in that 360 degrees. Digital root of that, 744, is 6. Okay, 6s all the way across here. So you have this pattern right here of this 9, 6, and 3, and then 6 right here, and then the total number of eclipses that occur in there. Again, now moving adding this one inside of this block. So this block is going to be 2, 2, 3, 2. That's the total number of eclipses that occur within this whole entire block right here. That's going to give a 9. Total time duration again is 1059, same as on the other side of the sheet of the paper. That's going to be a 6. Total number of moons, orbits around the Earth in that same time duration right here in years is going to be 13,098. Gives you this 3, 6, and 9 pattern. Right? 3, 6, 9, 9, 6, 3. Okay? 6, 9. 3, 6, 9, 3, 6, 9. There's a 3, 6, 9 connection that happens all the way through that whole thing in there. You think that's full of shit in there, or you think it's all just a lot of mumbo jumbo or something? Think again. Go check it out. Go look. You can do all this math yourself and go find that all this right here is absolutely correct. Every single thing in here is flawlessly correct. Okay, moving on to the next one here. This is the last paper that's going to be in this video. This right here is, you can see right here where there's these this 1632 right here. There's a 1632. Okay, 14, 15, 16, 14, 15, 16. So what this really is right here is an extended line of this line right here. Okay. Because it has the reason why what's important about this paper is to be able to see the 1,803 year cycle that there is in this, where it will start itself over, because you can see the 0824. It's going to go through here to here and start over. There's the 824. You can see right here the 24, 25, 26. 24, 25, 26. This happens over a time duration of 1,803 years exactly. The exact number of eclipses that happen in there is 3,800. And the total number of moons is going to be 22,300 orbits of the moon around the Earth. These right here are the dates that are of their occurrences and their non-occurrences. Again, they do align to their quarters, all of them, but according to NASA and the SARO cycles, only the green ones will produce an eclipse. This whole entire line right here is all the spring line. All of these will land on within 36 hours of their spring equinox, including the ones that evidently don't produce an eclipse. It will still go to its quarter within 36 hours of a spring equinox. Okay, so stay focused on this one right here. You can see, let's go start from back here, back in time. Back in time, you have these non-occurrences. First one that occurs on this line right here is going to be 1290. You got one in 1309. Does have its quarter alignment to its spring equinox line, but no eclipse occurrence. No eclipse occurrence. Now you have an occurrence. Yes. Eclipse occurs. Eclipse occurs. No occurrence. No occurrence. Okay, so we're moving up in time. We're going to get to 2015. Now we have a string of occurrences that are going to happen in here. You see the green ones. So you get to this 2425. That's the last one. Then 2740. It goes back into where it's, dropping off mostly. Get one in 2797 that occurs. Again, within 36 hours of the spring equinox, aligned to its quarter, 90 degrees from the galactic plane. Then the rest of these don't exist. So again, same thing happening here where we have these occurrences that happen within this now time. So now it organizes itself from nothing back here. I don't think I pointed that out on this right here. But the 1290 is the last one. The rest of these right here, all these down here are moving back more in time. Non-existent on the Saros cycles. Okay, moving it forward in time, and it gets itself organized. It gets itself well organized, and all these happen within this now time, within our current time. And then they go back out of existence again. On the other side of this right here, because this is the spring, this is this line in the middle right here is winter. But I didn't give that on here because I don't give the listing of dates in here. I just can't put them on the paper right here. So we do have the fall, which is 180 degrees across from the spring. So you're going to be in the fall. I'm going to point that out again, remembering that this is right here. There's the fall. There's the spring. This right here now is going to be the fall line. Okay, starting back in time. This one right here just ran short on the paper. I can only fit so much stuff on some of these papers right here. So this one right here directly across from this spring equinox is going to be over here in the fall at 1243. Now this 1243 is 143.75 plus another 143.75 takes you to this 1243 right here. So so every one of these is going to be the same thing. They're going to be the time duration from here to here is 143.75 years. From this one to this one is 143.75 years. Okay. So that's the same as every single one of these across here. So you can see back in here, this 1243, I'm pretty sure that that's the last one on this string right here. There are no other ones that will align on the fall. The rest of them are all red. That's what I'm saying down this way. All non-occurrences. So you get this occurrence in 1243 right here. Occurrence, non-occurrence, non-occurrence. Starting to occur right here. Just getting itself organized. Okay. Look at that string of green ones out there, right there. All these are going to be occurrences. All on the Saros cycles. Solar eclipses. Here's our now time right in here. You get up to 2321 and it drops off. Non-occurrence. 2340 it does occur. Get some right here that do. Not. One more that has 2731. And the rest of them are all not there anymore. Back all the way back. Not just right here. All the way back. They're gone completely. They don't exist anymore. Okay. So, whew. Somebody else has got to ask themselves a question as to how that happens. Right? How does it go from nothing back here? Does not have that order. Starts to find that order in here. Moving. This is moving backwards in time now. So actually, explain it over here. Goes from back here. Starts its order right here a little bit in the 1243. Moving up in time. The order's getting more defined. Okay. Okay, that's it. I'm done.